In question 11, the equation of a curve is y equals to k square root of 4x plus 1 minus x plus 5, where k is a positive constant. We have to find the dy dx. So to find the dy dx, this will be written as k into 4x plus 1 to the power of 1 upon 2 minus x plus 5. So finding the dy dx, will multiply 1 upon 2 by k. So this will become 1 upon 2k. 4x plus 1, 1 upon 2 minus 1 will become minus 1 upon 2. Derivative of x is minus 1. And we'll also multiply the derivative of 4x plus 1, which is 4. So we'll multiply the 4 over here. And the derivative of 5 will be 0. So we can write this equation as 2k upon 4x plus 1 minus 1. So the dy dx will be equals to 2k upon 4x square root of 4x plus 1 minus 1. And we can first write this equation as y. So dy dx will be 2k upon square root of 4x plus 1 minus 1. We have to find the x coordinate of the stationary point in terms of k. Now the stationary point means that the dy dx will be equals to 0. So we'll write it as 0 equals to 2k upon square root of 4x plus 1 minus 1. Taking the 1 on the other side, we will get 2k upon square root of 4x plus 1 equals to 1. Cross multiplying, we'll get 2k is equals to square root of 4x plus 1. Now to find the x coordinate in terms of k, we'll first take the whole square on both the sides. So whole square in both the sides, we'll get 4k squared is equals to 4x plus 1. Now making x our subject, we'll get x is equals to 4k squared minus 1 divided by 4. In part C, it says that given that k is equals to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. Now, in the first step, we have to first understand that if we have a curve like this, and let's say this is the x and the y-axis, the tangent is making an angle of tan inverse of 2 with the x-axis. So this is the angle tan inverse of 2. Now we know that tan theta or tan x is equals to opposite over adjacent. So tan inverse of 2 means this would have been 2 upon 1, or the y value was 2 and this was 1. So now we can deduce that the gradient would have been, which is y, the change of y upon change of x. So the gradient of the tangent was 2. It means that the gradient of the normal will be is equals to negative 1 upon 2. Now, as we know that the gradient of the tangent is 2, we can now find the value of x to form the equation of the normal. So dy dx we know was given as 2k upon square root of 4x plus 1 minus k. So dy dx is equals to 2k upon square root of 4x plus 1 minus 1. In place of dy dx, we'll write 2 is equals to 2 and k value is 10.5. So this will be 10.5 upon square root of 4x plus 1 minus 1. Taking the 1 on the other side, we'll get 3 is equals to 21 upon square root of 4x plus 1. Cross multiplying, we'll get 3 square root of 4x plus 1 equals to 21. To find the value of x, we'll whole square both the sides. So whole squaring 3 into square root of 4x plus 1 and square root of 21, square of 21, we'll get 9 into 4x plus 1 is equals to 21 whole squared is 441. 441 divided by 9 is 49. So 4x plus 1 will be equals to 49. So 4x is equals to 48 and x will be equals to 12. Now, once we have the value of x, we can substitute this value of x in the equation to find the value of y. As y was given as y equals to k square root of 4x plus 1. So we can write it as 10.5 into square root of 4 x plus 1. So x is 12 plus 1 minus x plus 5. So in place of x, again, we'll put 12 over here plus 5. Substituting this value in the calculator, the y value will come out to be 66.5. So we have the point with on the line which will be x equals to 12 and y equals to 66.5. So this point at the tangent, x is 12 and y is 66.5. We have the gradient which is minus 1 upon 2. To form the equation, we'll write it as y minus y1, which is 66.5, is equals to minus 1 upon 2, which is the gradient, into x minus x1, which is 12. Now we can leave the equation as it is, or if you want to simplify, we can write it as 2y minus 66.5 times 2 is 133 is equals to minus x plus 12. So we can write the final equation as 2y is equals to minus x plus 12 plus 133, which is equals to 2y is equals to minus x plus 145, which will be the equation of the normal.